So predictions using linear regression. So this is one of the main reasons we do regressions is that in the real world, we talked about it, stuff is never perfectly linear. So what scientists or accountants or lots of different professions, what they do is they take the information that they have and then they try to find that average or that trend line that best predicts or tells them where the average is or what's closest to all of those. So that's why you really see linear regression in the real world way more than you ever see just lines. Um, so if you look at this, we're still going to find, we're going to make predictions based on this. So if I give you an x value of 0 and y value is 12.5, and then I gave you, and I asked, well, if x is 3, what would this be? So go ahead, sorry, I'm going to exit out of that. So I'm going to go ahead and type it in. So stat, edit. Anytime you're doing this, I've seen quite a few people getting errors or getting the wrong information. Remember, you always have to be in list 1 and list 2. If it's not already in list 1 and list 2, hit the stat button and go up down to number 5 where it says setup editor. It will just say done, and that will automatically put you back on list 1 and list 2. So 0, 1, 2, 12.5, 13, and 15. Okay, stat, calc, run your regression. So first thing you need to do, or step 1, find equation. So keep hitting enter. Oops, I hit enter one too many times. So my equation is y equals 1.25x because it says a value is 1.25 and then the b value is 12.25. Okay, now if I asked you to predict the y when x equals 5. So it's giving you an x value. So what you always want to remember is you have to plug this in for x in that equation. So if it told you, and we'll do one in just a second, if it told you predict x when y is this, you would plug in for y. So if it gives you the x value, you plug it in for x. So it'd be y equals 1.25 times 5 plus 12.25. So it's telling us this isn't a perfectly straight line, and you can tell that because the r value is 0.95 or 0.94. If it was exactly 1, it would be a perfect line. But since this is not a perfect line, there would have been some points below, some points above, some points below. So we're going to use 5 to find the value to this. So you can either do it in your head or just do it in your calculator. 1.25 times 5 plus 12.25. So y equals 18.5. If you kept going, 3 would be some number, 4 would be some number, and 5. So it went 12.5, 13, 15, so 16 maybe, 17.5, 18.5. So it makes sense that 5 could be 18. If you would have gotten something like 50, that would have not made sense at all just because this was only going up by a little amount each time. Sorry, there's the bell. So 18.5 is a reasonable number to get. So you always want to look at that and make sure that it makes sense in the problem. All right, so now let's do if we predict x. So if it said predict x, when y equals 25. So if y equals 25, so it would have to keep going from this. So I should get a number that's larger than 5. So again, it says predict x when y equals 25. So I'm going to have to plug in for that, not for the x. So it'd be 25 equals 1.25x plus 12.25. Okay? Now, this is not just typing it in your calculator. You have to actually solve to find the x value. We're trying to find x. So I need to circle my variable or isolate the variable. So what's the opposite of add 12.25? Subtract. And subtract over here. Goodness, my pencils keep breaking. So 25 minus 12.25 is 12.75 equals 1.25x. Okay, it's 1.25 times x, so the opposite of multiply by 125 is divide by 1.25 and divide by 1.25. So it would be 12.75 divided by 1.25. So 10.2 equals x. So it makes sense. Remember, these are only going by like 0.5s and 2. So it makes sense that this could go almost double because it's all the way up to 25. It only went from 12.5 to 13.5. It only went up 6 points in 5. So it makes sense that it could go up to 25 in 5 more. Okay? You will typically see these problems where it talks about like the years and the enrollment, or the years and the cost, or these will typically have some actual variable. It's not going to just use x and y. It's going to actually be talking about something. So pay attention to if it says the number of years is whatever, plug it in for the years. If it tells you cost, and this was the cost, then make sure you know you're plugging in for y. So pay attention to the x and the y value and see if it gave you the input, or if it gave you the output. So that is using linear regression to make predictions.